And thanks a lot for our embassy to invite us to speak about this topic. Thanks for the nice introduction. I will bring you through my presentation into which are our applications of specific branch of artificial intelligence that is specifically applied to geospatial data, to geoinformation data from space. Okay, well, I will start with this slide. It's about Digital Earth. It's a concept that Vice President Al Gore brought in 1998 and that today is becoming more and more true since nowadays satellites and sensors are collecting huge amount of data over the whole land masses and the Earth, and we have now the ability in terms of data, infrastructures,
Hello,
and
Mr. Bella.
analysis technology to extract sense and information out of this huge amount of data. But what we need is actually knowledge and tools. But today we are confident that we are at the beginning of what we can have the era of digital Earth really in place. Well, moving from this, actually this is a slide that at a glance is providing the activities that at EGEOS we are performing in geo-artificial intelligence. Well, EGEOS is a joint venture between Telespazio and the Italian Space Agency, and our specialty and knowledge is specifically on geoinformation. So data coming from different sources like satellites, airborne drones, but also other sources that are providing data that are geolocalized. And therefore, our main streams of geo-artificial intelligence address tasks like object detection, automatic target recognition, and anomaly detection. And to do so, we have built what we call the AI Factory, that is the platform where our data science team is working and cooperating to manage the whole life cycle of an AI model, because there is a lot of effort and knowledge to build an AI model, but we know, as we are an enterprise, that these models need to be put into operations and that you have to manage the process of developing and operating these models, also including updates. On the right side, I link to what Andrea was mentioning before regarding the Leonardo Labs, bringing you some numbers like the number of positions that have been opened by Leonardo for researchers in different topics like artificial intelligence, cloud, HPC, quantum computing, and big data. And in particular, 8 of these guys are dedicated to space technologies, and they are located in Rome in our premises. Good. Entering a bit into the AI factory, this is a conceptual schema, and it's important to mention how we manage in a single place data sources that become training data sets, and this is really a value and an asset of our company with a catalog of training data set, and to train AI models. Now, I will go back to this since we are more or less all using available models in literature, moving them from, let's say, a domain to another, since the domain of satellite imagery is totally different from the domain of common use objects, but it works. Of course, there is a lot to do to build AI models that are specifically designed for the space domain. And here you can see how different profiles can cooperate on these platforms. So data analysts, they build the models, they maintain training dataset, and they can count on an annotation task force. While production and operations, they can use and exploit published AI models in their data treatment processes. And this is actually how we are bringing science into operations. And this is very important to us since we have the objective, of course, to extract new contents or to streamline and optimize current tasks that we are performing. Well, to do this, we have a federated artificial intelligence teams. So we have an AI team in EGEOS and GAF, that is our company that we own in Germany. That is quite a large team. We have a small team in Telespazio and also the contribution from the Leonardo Labs. These teams are cooperating and they're working at different TRL level, since Leonardo Labs is addressing a bit lower TRL, but this is actually where we have to invest today to be able to have a competitive advantage tomorrow. Good. And coming also a bit back to what Andrea was mentioning about the large HPC infrastructure installed in Genova as part of the Leonardo Labs, well, this is very, very relevant since it can be federated also with other smaller HPC infrastructures. We have one local in Aegeos since we are processing large amount of data for INSAR, so for interferometry, since 20 years, and therefore we have, let's say, culture and knowledge about the deployment and operations of an HPC infrastructure. But having the possibility to access such a large supercomputer like DaVinci-1 in Genova is for us is fundamental to speed up the training and benchmarking of AI models, because with federation of multiple GPUs, we have the possibility to do essentially two things. The first thing is to do such a large scale training using so many data that it would take ages in other infrastructures. And so we can use brute force to perform this task. And the other thing is that we can compare many different AI architectures at the same time, and therefore converge very quickly to the best AI architecture to be used for a specific challenge. And therefore, ultimately, it helps us to reach our objectives and results more quickly. Okay, but how we are actually using artificial intelligence in what we call geo AI pipelines? Well, actually, we have 4 main steps. First thing is, data crawling, so getting the data and pre-process the data so that they are ready to be, let's say, packed as a training data set. So this requires some effort, and it has been streamlined so that we do not have to, let's say, spend the time anymore in doing this manually. Then, of course, we have the first phase of model training. So we start from, let's say, a naked AI architecture, and we train it with available training dataset for the specific task. And so we have now a trained AI model that can be used in the second step for inference, which means that we are using the trained AI model to actually apply it to new data, so to data that were not seen before by the AI model, and to derive results, which can be good or bad. So we don't have, let's say, the it's not the ambition, but let's say the objective to have the full result at once. But we know that in some cases you need manual intervention, and this is why we have built tools also to support our cartographic production unit to be autonomous. So they are not data scientists, but they have the tools, for instance, to manage the retraining of the model with some small amount of local training data set. And this dramatically increases the accuracy of our results and also the fit for purpose of the data that we are producing, supported by AI. And most important, we have a production team that is very happy and that is saving time, and that has the possibility to use this time where it matters most. And so this is how we have found our way for a geo artificial intelligence pipeline. Okay, this is just a quick overview of the current AI inferences that we have in place and that we have working on both optical and SAR satellite data, but also on data captured by drones. They are very heterogeneous, and the important thing is that we have now a capability to quickly react to any new challenge. Once we have, let's say, sufficient amount of training data, we are really fast in building a model and putting it into production. Of course, this is not, let me say, rocket science, but is, let's say, a bit of optimization and streamlining of existing tools. But what's beyond? Because this is now operations, but we are very active also in the research area with several research projects funded by Italian institutions, but also by European and international research programs. We are very active in this field, and we are also very open to cooperation. Well, actually, we are working hardly on target detection and recognition. This means in being able, for instance, to train deep neural networks using simulated data, in particular in those cases where there is a scarcity of data. And so, for instance, for SAR data, it is possible to simulate them starting from computer-aided design models, and therefore to build a library of these kind of targets. And we are seeing that this approach is bringing really good results, and it can be, let's say, applied virtually everywhere, and it is scalable thanks to the platform that we have built. Second, area that we are doing active research is, of course, anomaly detection. Now, I will not go, let's say, into the thematic details, but for us, anomalies can be applied in different contexts. Now, I'm showing here some maritime examples in finding anomalous behavior of different vessels, both from observations from satellite combined with information coming from AIS. But you have to think that this applies almost to any use case. Also, for instance, thinking about IMINT, or also thinking about civil applications like, for instance, agriculture and crop monitoring. And we know that today all these items are really interconnected, since, for instance, food security elements have also an impact on, for instance, fragile states and stability. Okay, this is a topic on, activity-based intelligence, that actually we are changing a bit the paradigm. So we are going more towards a paradigm of georeference to discover. So fusing different branches of intelligence like UMINT, CGINT, OSINT, and IMINT to build, let's say, a comprehensive picture of what's happening in a certain space and time. Clearly, we are fusing satellite data with also information coming from social media and news. This is very important because we are able to combine a different perspective. So what is the satellite observing? What are citizens also reporting in social media? And this is very important to reinforce information and to build knowledge. Well, clearly it's important for us also to bring AI on board of satellites, because in this way we are able to derive information much faster, and also to streamline the quantity of data that we analyze. And this applies actually to any kind of sensor and agent. And here I come to this very important research topic for us, that is being able to have multi-agent mission management, so to have methods and tools for mission planning, perception, and navigation of agents. In this case, it's about drones, and it implies a lot of different tasks. This is one of the most important research projects carried out in the framework of the Leonardo Labs, at least on our side. And clearly, I have also a slide on explainable AI, so very nice also the presentation of the speaker before. And I can just reinforce that this is an area where we are all investing a lot, because if we want to bring and to use artificial intelligence into mission critical operations, then we need to be able to trust it, and also to explain why a decision has been taken in a certain way. This is very important for aeronautical certification, for example, but also for geoinformation applications. And this is also where the fact that we have a cross-divisional and a full Leonardo Lab capability is helping us to build this future. And Mr. Chairman, this is my last slide, and I'm over with my presentation and time. Thank you very much.
Thank you, Domenico. You are invited now to give any questions to all of the presenters, anybody.
Yeah, I would like to know in the application field if we have to talk about border control on the ground. Do you have something related to that you can provide, and just some examples from border control?
Yes, of course, they can be provided.
Any other questions?
I have a question actually. I have a question for Domenico. In an environment where there is hazards at work, like for example, mining company or refineries, your behavioral or anomaly detection with some cameras can predict an anomaly in human behavior to pick up if some of the workers are stressed and they are not fit for work or can be dangerous for them to work.
Okay, so it's a very interesting and relevant question. I have to say, and I have to be honest, that this is not our main field of expertise because we are looking, let me say, not at the specific worker or at the specific agent. Of course, the kind of research that we are carrying out in the Leonardo Labs, and there is one specific research project on anomaly detection, can certainly focus on this kind of application, because also think that Leonardo is a very large company, and for instance, we care also a lot on helicopters, avionics, and therefore there is also a big focus on pilot health and stress. And so this kind of concept can be surely transferred into this other domain.
Thank you, Domenico.
My pleasure.
Any other questions from Pretoria online?
If I may, also a question to Domenico. You mentioned workflow pipelines. Are you developing or are you making available environments for scientific workflows like Kepler and so on that are used in the EO domain? Is that available?
Yes. So what we make available is a development environment.
Okay.
So we are releasing it. We are the first users of our development environment, and we are opening it also to science and entrepreneurs. So to have actually a platform where you can build scalable processing workflows and care more on the thematic part of building an application rather than having to concentrate on managing the infrastructure below. So
Right.
it's a platform as a service, and we are very keen to getting this used and shared and to build a community that is using it and that is also possibly improving it.
Well, thank you.